There's a planet about 750 light-years from Earth that orbits a dead star the mass of our Sun, but the size of a small city. Gravity has squeezed it into the shape of a lemon. Its atmosphere is made of carbon soot, and deep inside, that carbon is probably being crushed into diamonds. When the scientists who studied it got their data back from the James Webb Space Telescope, their published reaction in an actual peer-reviewed paper was, quote, "What the heck is this?" We're going to get there, but first, we need to talk about a few other planets, because the universe has been producing some deeply unreasonable worlds, and this lemon is just the latest in a lineup that gets progressively harder to believe. Start with WASP-76b. It's a gas giant about 640 light-years away in the constellation Pisces, and it orbits so close to its star that one side is permanently locked facing it. The day side reaches around 2400 degrees Celsius. That's hot enough to vaporize iron, not melt it, vaporize it. Actual iron turned to gas. Winds then blast that iron vapor across the planet to the cooler night side, where it condenses into liquid droplets and falls as rain. It rains liquid metal on WASP-76b, and not gently. The winds carrying that iron are moving at several kilometers per second, supersonic. This is not a drizzle, it's a sideways metal hurricane. David Ehrenreich, the astronomer who led the discovery team at the University of Geneva, put it simply. One could say that this planet gets rainy in the evening, except it rains iron. Worth noting that WASP-76b is a gas giant. There's no surface for the iron to land on. It just falls through layers of increasingly dense atmosphere until it re-vaporizes and gets blown back to the day side to do it all again. An eternal cycle of metallic weather that makes British drizzle look aspirational. Now meet Tries 2b 750, light-years away in the constellation Draco. This is the darkest planet ever found. It reflects less than 1% of the light that hits it. For comparison, Jupiter reflects about a third of the sunlight it receives. Our Moon reflects about 12%. A lump of coal reflects around 4%. Black acrylic paint manages about 5%. TRES 2b sits below all of them. If you held coal up next to this planet, the coal would be the shiny one. David Kipping, the astronomer who made the measurement, described the detection as being like spotting a fruit fly crossing the beam of a car headlight. The planet's atmosphere contains light-absorbing chemicals: vaporized sodium, potassium, gaseous titanium oxide, but none of those fully explain why it swallows 99% of incoming light. Something else is absorbing it, something we haven't identified. And despite all that darkness, Tries 2b isn't invisible. Its surface temperature, around 1000 degrees Celsius, means it glows a faint, angry red. A vast black sphere the size of Jupiter, barely visible against the void, radiating a dull ember glow. I'd call that unsettling, but I think the planet would absorb the word before it landed. Those two are dramatic. The next one is just confusing. WASP-193b is 50% larger than Jupiter, bigger in every dimension. But if you could somehow weigh it, you'd find it has only 14% of Jupiter's mass. Its density works out to about 0.059 grams per cubic centimeter. For context, cotton candy, the stuff you eat at fairgrounds, has a density of about 0.05. This planet is, in terms of density, essentially cotton candy, 1% the density of Earth, an entire world made of what is functionally air. The team that found it, led by Khalid Barkawi at the University of Liège, spent 4 years trying to measure its mass. Usually, a Jupiter-sized planet yanks noticeably on its star. This one's gravitational pull was so feeble they kept thinking they'd made an error. Francisco Pozuelos, one of the co-authors, admitted they repeated the entire data analysis multiple times because the density was, as he put it, super rare. Julian DeWitt at MIT called it basically super fluffy. No existing model of planet formation can explain how WASP-193b inflated this much, or how it stayed that way around a star that's roughly 4 to 6 billion years old. Every theory says it should have deflated or been stripped bare by stellar winds eons ago. It just didn't. Which, for a planet made mostly of nothing, is a surprisingly stubborn thing to do. From a planet that barely exists to one that's been turned inside out. TTTO 849b, about 730 light-years from Earth, appears to be the exposed core of a gas giant. Something ripped its atmosphere off. What's left is a ball about the size of Neptune, but with 40 times Earth's mass and a density similar to our own planet's: iron, rock, and water, with almost no hydrogen or helium. A gas giant stripped down to its skeleton. It orbits its star in 18 hours, 1 full year, shorter than a day here. And because it's so close to the star, any wisps of atmosphere it still has are being continuously boiled off and replenished from the core itself. Which means that if we can study that thin atmospheric skin, we're effectively reading the recipe for a gas giant's interior. We've never been able to do that before. Not even for Jupiter. Christophe Mordassini at the University of Bern, who led the theoretical analysis, said the tiny amount of hydrogen and helium remaining was really astonishing for such a massive planet. It should have held onto far more gas. Either something tore it away, tidal forces, a collision, relentless radiation, or this planet simply never finished forming. A cosmic rough draft that got published anyway. And then there's one that won't be around much longer. In early 2025, Mark Hahn at MIT spotted something unusual in test data from a star in the constellation Pegasus, about 140 light-years away. The transit signal, the dip in light when a planet crosses in front of its star, was fluctuating, changing depth with every orbit, and it was taking far too long to return to normal, as if something was smeared across the sky behind the planet. It was. BD plus 054868 AB is a rocky planet roughly the mass of Mercury, orbiting 20 times closer to its star than Mercury does to our Sun. Its surface is covered in boiling magma, and it's actively disintegrating. It trails a tail of debris roughly 9 million kilometers long, 23 times the distance from Earth to the Moon, covering more than half its entire orbital path. Every 30 hours, it sheds a Mount Everest's worth of rock into space. Hahn described catching it on its last breath. The planet has maybe 1 million years left. In cosmic terms, we walked into the room just as the candle was going out. Which brings us back to the lemon. PSRJ 2322-2650b orbits a millisecond pulsar, the collapsed core of a dead star about the mass of the Sun compressed into a sphere maybe 15 kilometers across. That star spins 300 times a second, faster than a Formula One engine at redline. The planet whips around it every 7.8 hours. Its year is shorter than a work shift, and the pulsar's gravity has pulled it so severely out of shape that its equator is 38% wider than its poles. A planet stretched into a citrus fruit by a star the size of a city. In December 2025, Michael Jiang at the University of Chicago published JWST observations, revealing that this planet's atmosphere is made almost entirely of helium and carbon, specifically exotic molecular forms of carbon that shouldn't exist stably at these temperatures. No oxygen, no nitrogen, no water, no methane, nothing we'd expect. Carbon soot clouds float in the upper atmosphere, and deep below, under crushing pressure, that carbon is likely condensing into diamond. And there's one more detail that almost nobody has covered. The planet's atmosphere is rotating backwards. The winds are streaming westward while the planet itself is locked spinning eastward with its orbit. The sky is moving in the opposite direction from the ground. Jiang said the composition seems to rule out every known formation mechanism. This planet shouldn't exist the way it does. It doesn't fit the model for normal planet formation. It doesn't fit the model for stripped stellar companions. It doesn't fit any model. We've confirmed over 6,000 exoplanets now, and the honest takeaway isn't that we're getting better at understanding them. It's that the more we find, the more we realize our solar system gave us a deeply misleading sample size. 8 tidy planets, all roughly in the same plane, none of them raining iron or shaped like lemons or dissolving into space. We thought that was normal. It turns out that might be the strangest thing of all. If one of these planets genuinely broke your brain, tell me which one in the comments. And if you want more of this, subscribing is the fastest way to make sure the next one finds you.